Welcome back everyone. In today's video, decision tree classifier. We will predicting customers' behavior today. So these are all the topics we will cover in this video. Hello everyone. Today we are building one of the most intuitive model in AI, the decision tree. Think of it as teaching a computer to play 20 questions. We are going to use this model to look at customers' data and predict whether some people or any customer is likely to buy a product or just walk away. The power of the choice. So, what is it? A decision tree is essentially a flowchart that turns data into a series of yes and no questions. It starts at the top and then branches out. By the time you reach the bottom, the computer has filtered through all the noises to reach the final decision. This is a simple structure of decision tree. It's the root node, the main decision node from where the tree started, and then it is divided into subtree, different branches, and then the subtree in this there are simply sub questions, smaller questions, and then the leaf node, just like two categories, yes or no. It's just an example of the decision tree. And there can be in the branches, there can be a leaf node, just answer yes or no or any class, or there is another question that has two, that has two or more answers. So, predicting customer behavior. Businesses uses this every day by looking at attributes like age, income, or gender. We can find patterns. The tree learns from the past to predict the future. If the tree sees the most people over 40 with high salaries buy a product, it creates a rule to capture that behavior. It's a simple example of decision tree, how it grows and different branches. Moving forward, first of all, we start with the root node. Every tree starts with a root node. This is the most important question. The computer looks at all the figures and all our features and asks which single question splits our customer into the cleanest group. The question becomes our starting point. So, in this example, this is called, or this is the root node, and then there is discussion 1 or discussion A, discussion B, then chances, chance node, then another chance node, and in last the end nodes, the outcomes. There are different categories between these two and these two. One is selected from here and one is here. Then there are only two choices and only one is selected. In this, just take example. Imagine A is selected, then the answer for this node is A, discussion A. And now it's time for the branches and internal nodes. From the roots, we grow branches. If an answer to a question is yes, we go one way. If no, we go the other. The point where we ask follow-up questions are called internal notes. It's like a detective narrowing down suspects by asking more and more specific questions. In this, it's the internal node. The first one is the branch node, which is our starting point of the tree, and then there are branches, different branches. And if another question arises after the starting node, then it's an internal node, which is used for asking more and more specific questions. And then it has specific answers, like there are two different leaf nodes. So this is how it goes. And the last thing, the leaf node, the final answer. Eventually, the question stops. We reach the leaf node. These are the ends of the road. A leaf node doesn't ask a question, it gives us the final answer. Just the final answer. In our case, it will simply says this person will buy or this person will not. Simply a customer buy or not. As we are using or we are going to predict the customer's behavior. So in our case, it simply can be a customer will buy something or any product. A customer will not buy that product. Here you can see the node, and there's the this is the leaf node. As there are no another sub questions, the internal nodes present, or if any internal node are present, then their branches are the leaf, the end branches where the questions are stopped or it comes to a critical point where no more questions left, just the answer or just the class is left, then that is our leaf node. Let's go and how the tree learns. How does the computer choose the questions? It uses a math concept called entropy. The entropy is just a fancy word for disorder. Here you can see the entropy, the disorder. There are two different classes intermixed with each other. They are not in any specific sections or in any specific order. They are just in disorder. That's why it's this is the entropy. The tree wants to reduce the disorder. It picks questions that turns the noisy mix of buyers and non-buyers into clean and separate groups. Then from the total number of orders from whole first people in a shop, it uses different questions, specific questions to make them in proper order, in pure order with zero entropy. Here you can see this is the root node, this is the internal nodes, and then these are the leaves where we can see it's with zero entropy, pure in order. There are five orange balls, and there are two green, and there are four red and three orange. Each one is separated from each other in proper groups. This is how our tree works. This is the main, or you can say this is the major rule how our tree works, learns, and works. Moving forward, Categorical and numerical data. Decision trees are very flexible. They can handle numerical data like is the salary over $50,000 and categorical data like is the customer is male or female. We don't need to do a lot of complex math to make these different types of data work together. Sorry. Here's the example, the income example, and the customer living example here, the city or the village. We can see the main root is two the variables, and there are two different categories, the categorical and the numerical data. And in categorical, we have nominal and we have ordinal. In nominal data, this data shows each one is separated from another. They are not dependent on each other, like male, female, or colors like red, green, black. But in ordinal data, they are dependent on each other, or they are in sequence proper, like small, medium, large, or the grades or the letters A, B, C, or just an example of the positions first, second, and third, like that. And in numerical, we have discrete and continuous. Discrete like a specific number, like 568 people. Here's the example of 568 peoples, or one, two, or three businesses. But in continuous data, we have like a range, the age or the height. So these are the categorical data and these are the numerical data. Let's move forward. Here we start, prepare the data. In our code, we start by loading our data into a pandas data frame. We tell the computer which columns are our features, the clues, and which columns is our target, the answer we want to predict. We also make sure categoricals or data or like the categories like gender are turned into numbers so maths can run easy. So before moving forward, let's get to our coding section and start coding side by side. So simply start with Jupyter Notebook. Let's go. In course, we will create a new Python file. Just wait for a second. Here we start. Let's rename it as decision tree, and we are going to start by importing some important libraries first. Then we will create our data set. First, we will import pandas as pd, and then from sklearn dot model underscore selection import tree test split to split our data properly. Let's split. Okay. Then again from sklearn dot tree. It's sklearn dot tree. We will import the decision tree classifier tree classifier plot underscore tree, and we have imported two things, the decision tree classifier and the plot tree. Moving forward, once again from sklearn, just give me a sec. Okay, here we are again from sklearn. We will import matrix, matrix, and lastly we will import matplotlib dot plot as plt. Simply we will run this. Oh, indentation error. This is the one of the most annoying error in Python. From sklearn, sklearn is no matrix, matrix. Here we go with some small mistakes, human errors. We are back again. Now we will create our data set. So we are creating data set 3, creating our first data set only. So in this, we will use the features, the age and the annual salary, and the third one is our gender. And the target value is bought or not, yes or no, is our customer is going to buy something or not. So we will using the features. So I think I just create the data set and tell you where or which are the features we are using and which is our target value. So we are using the data. This is our variable name data. And here, firstly, we are using age. Just a second. Here we go. In age, we will create a list and we are giving some random values. And next one, I think 46 is good and 46 and 56. 22 again, I think just good one. 39 more, more 41 and I think 49 is good. Yes, we have how much we have done? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we will using 10. I think 10 are enough. 10 people or 10 customers are enough for explaining you so you can understand it easily. And for the further practice, you can download dataset from anywhere, from any site on the internet, and use this model for practice and you can predict new data by yourself. Okay, so this is our first picture. The next is salary. In this, we have to mention 10 salaries starting from 20,000 and some random 35,000 and 1 lakh 15,000 50. I think 1 lakh 50. It is, that's good. 90,000 and 61,000. Oh, 6 lakhs are too much. 61,000 is good. I think 13, no, 1 lakh 30,000 is good. And 27,000, then one thing 80,000 and one with 50,000. 1, 2, 3, 4, 5, 6, 7, 8, 9. The last one we will go with 36,000. I was about to say 63,000. It's 36,000. And then again, comma. And the third feature is our gender. And I am just, firstly, I will tell you this is for zero, for zero, I am using it for females, and for one, using for male. I'm not, I'm not here differentiating both of them or starting any controversial statement. These are both male and female are independent units. That's why I simply, for easy calculation, I am using 0 and 1. So, no offense for any gender, just doing my job. First, we will use the female. Again, I think female is good. And then with two females, I think, and men, male, female. How much? These are five. One, two, three, 4, and 5. And then male, that one is 6. And then female, male, 1, 2, 3, 4, 5, 6, 7, 8. I think we will use last two as females. Okay. The last variable. First, we have to put a comma here. Oh, sorry, we have to put a comma here only. This is whole. This whole thing is a comment, and the last column is our target column, and we are using it as bot. Is the customer is going to buy that product or not? So for this again, I am simply using 0 and 1 as for ease calculation. So we will use 0 for no and 1 for yes. Okay, so here we go. Just like 0, space 0, and they will buy. They also going to buy, again buy, and for this we will buy it again, and no, and buy, and for the last, is this the last? No, we are going exactly the same on the last one. Again, 0. Okay, here we go. This is our data set. We have created our data set manually. I simply created a small data set for ease of ex- explaining, or you can understand this easily. But for your practice, I recommend you to go and download some bigger data, some larger organization data. You can download it from any source like the Kaggle or GitHub. You can find lots of different CSV files or the data files there. You can use any of them for the practice purpose. And before doing the practice, just go with this flow and understand this properly. Now we will creating our data, converting our data set into a data frame so our model can use it properly. So pd dot data frame, and in this we have to give the name of the variable data which we are going to convert into data frame, and for the x value we are dividing the, oh, these are our features for x, these are our features. So as I already told you, we are going to use our first three columns as our feature and the last bot column as our target. So these are our features: age, salary, and the last thing, gender. And this is our feature set. These are our features. Let's simply comment here features and their df, and we are using both prot or not. We are using this, and this is our target. So we have converted our data set into data frame and simply divided our features and target. So these three are our features: age, salary, and gender, and prot is our target. Simply run this. Here you see with no error it runs. And before moving forward, let's get to our presentation back and check which step is next. Here we are again in our presentation, In this, we completed our data preparation and we're going to the next step. Step second, splitting the dataset. I was right. Splitting the dataset is the next second step. We never test a model on the same data is it studied. That would be like giving a student the exact same questions from the practice exam on the final test. We split our data 80% for the tree to learn from and 20% test its real world intelligence. So this is time for splitting our dataset in the ratio of 8 ratio 2, the 80% for the training purpose and the 20% data for the testing purpose. Let's move back to our coding part and split the dataset. Here we are. The next thing is splitting, split plot. It's split data. We are going to split our data. We are going to split our data in the 80% for the training and the 20% for the testing. Let's start with variables, xtrain, xtest, and then ytrain and ytest. We will use it as for here. We are using train test split, which we have imported here, train test split from the model selection. And in this, we are going to give the parameters, the x, our features, the y, our where it was our target value. Okay, the target column. X is our features column. There are three different features on which our model is going to be trained and is going to be predicted for the last column. And we have done our feature and our target. Then we have to divide or we have to give the test size variable size test size as the parameter, and in this we have to give 0.20, oh sorry, 0.2. 0.2 is for the 20%, 20% as the test data, and the remaining 80% is automatically going to be the training data. Okay, and the last random state where it's going to be started, and we'll use the default number 42. Here we go, and simply we will print more data. Data is prepared and split. Data is prepared and split. This is enough. And now we will predicting. Oh, sorry, we will printing our head with checking how our data looks like, how our data is going to be look like. Just move, and here you see. As I already told you, the head function with the default parameter gives you the top five elements or the top five rows of your data. So these are the top five, and if you want data from the bottom, you can use the tail function data, sorry, df dot tail. Here you see we have age, salary, gender. These three are our features, and the bot, this is our target. Using these three, we are going to predict is our customer is going to buy the house or buy any item or not going to be buy. Okay, let's moving back to our presentation and let's check which is the next step to be proceed with. Here we are again moving forward to step 3, training the model. Now we grow the tree using sklearn. With the first command, the computer scans our training data and builds the logic. And it figures out the best questions, the best branches, and the best leaves nodes in a fraction of seconds. Here's the full structure of the decision tree. In this is the root node. We have the root node, and then there are the internal nodes, the discussion nodes, and the leaf nodes. Here they are the terminal nodes. These are the leaf nodes. In fraction of seconds, the discussion tree model simply algorithm in fraction of seconds, this discussion tree algorithm simply selects any of that internal node, and from that internal node the specific outcome or the leaf node, then it is going to be its outcome only. So let's train our model and see how it's working or how it's be going to be predicted. We are back to our coding section. Let's this thing we will first in this section we will first initialize the classifier and then we will train our model. So first, we will use entropy as the creation. First, we will use entropy to measure the purity of the states. Let's initialize first. Initialize first. We will use variable as CLF, and this is decision tree. Classify, classifier, and in this we will give the variable. And for this, we will use copy. Here we go. And the next thing is the max depth, the depth of the decision tree. And then we will train, train our model here. And this is where the tree is going to be learn the patterns from the training data. Let's go. We are using training. We are going to train our model. So we will use dot fit function for that. And in dot fit function, we are using two variables, x train and y train. And simply for checking is all the data points are working properly, all the coding part is working properly. So we will in last print the decision tree and finish training or simply finish growing. This is the length of our decision tree. Simply run this. Here you can see the decision trees has finished growing. So each of them is worked properly. Let's move back to our presentation part and see the next steps. Then we will come here again and do further coding. Let's Here we are again. Moving forward, visualization. One of the best thing about this model is that it isn't a black box. We can actually plot the tree and we can see every question the computer is asking. This makes it very easy to explain the AI's logic to the boss or a client. So here's the example how this model works. Here, if we have the root node as the income, how much a person or different persons income is, then it first divide it in age, is he or she a student or not, then CR, and then for further you can check his age is 30 or less, and here's the 31 to 40. And if the student is yes, and if the no, then is his or her age is less than 30 in the range of 30 to 31 to 40 or greater than 40, then CR or not, fair and excellent, like that. This is an example. So before going and doing the coding part for this section, let's check the next one also. Here we are, the danger of overfitting. We have to be careful not to let the tree grow too deep. If it is get too complex, it starts memorizing individual people instead of learning journal patterns. This is called overfitting. We prevent this by setting a max depth to keep the tree a specific and effective. Here's the example. This is the actually it's a graph. I In simple words you can say if a model is overfitted, then it not learns from the given test or sorry given training data, it memorizes each person. And if we provided the in the test part, if we provide the same person's details, the model's accuracy can be over 99%. But if the testing data is new or unseen, then the model accuracy goes be low as 20 to 10%. Just a fair or simply like a guessing technique. As because in overfitting the model not learns the specific patterns of the data, it memorizes only the particular age or the particular customer's details. Then it can only answer about that person only. It do not generate any specific patterns to work with. So this is the training data. The this is showing if the model is overfitted, then the model is high as it is more complex and it is learning each individual's data or each individual at a time. But during the testing phase, here you can see for the starting few, the accuracy, the test accuracy is higher, but then with moving or increasing the size, the accuracy goes down as this is the unseen data, but the model is overfitted and only good for a particular data that or on which the model is trained. So moving forward, checking the accuracy. Before moving forward, let's go and complete our coding part and let's check our accuracy score. Here we are again. First, we will complete the visualization part, then we will predict and we will then check our accuracy. First, visualization part, visualization part. In this, we will plot some graphs, bigger, and in this big size equals to, we have to give the size of the graph. This is good enough. And then we will use plot tree. In this, we are going to use a model. And just a second. Yeah, here we go. Simply we first our model and then feature name as or we will give all the features, age, salary, salary, and the last thing is gender, and then we will give the class name. Class name as not by and by, and that we will use print true properly fill this and rounded also true for our graph to be perfect and easy to understand. Then we will use plt.title, and in this we are simply decision tree. This is our title. And last plt.show. Using the show function, we are going to check okay, the figure size is this name error. It's plot. Oh, by mistake, I written as plt. It's plot. That plot which we have imported here, we are going to use this and simply run this. What's the what any feature name? Oh, sorry, feature names, not name, and also the class names. Just here, the class names. Now going to be perfect. Here you see, I think the size is too big. Should we reduce the size? Then six. No, this is was earlier was if we press 10 14, you can see it's a little more visible. True or false? Salary. If the salary is greater than 48,500, then the entropy is 0.95. The entropy is too much. We have samples total of 8. We have values 3 and 5. Classes are by, and this is for the both buy and not buying. The classes are both. This is our whole data, and we here we have higher entropy. But if we check if this is true, this is not for buy, as the customer is not going to buy anything or not going to buy that product. Then there are three different samples here in which the customer is not going to buy anything. It means three customers are like this, which are not going to buy anything. The value are zero, and this value is reduced to zero. Oh, sorry, three, and this value is reduced to zero as this is the false entropy in which the customers are going to buy, and this is for the class where customers are not going to buy. And in this, we have five different samples with values of 0 to 0 and 5. And in this class, this is for the buy. And you can see both have the entropy 0 and 0 as the data set is properly classified or divided in pure order. Here the entropy is high as 0.954 because the data set are intermixed with total as the total sample values are 8, but three values are from the not buying category, not buying class, and five values are from the buying class. So this is for the visualization part. Let's move ahead and check our accuracy. So checking accuracy. This is our next step, checking accuracies. So we will use y predict, and in this we'll use predict and x test. This is going to be here. We will use predict function with our model. We will use dot predict function, and in this we have given the parameter x test, the testing values which the testing data set which are we have separated earlier for the testing part. So here's the testing part, and now we will check the accuracy. For this we will use a variable name as accuracy matrix dot accuracy dot score, and in this we will use y test and y predict. The y test is the actual output of the testing data or the unseen data, and y predict is the predicted data of our model. Okay, so now we will print the accuracy. We will use f string here, accuracy, and in this we will use so 100% here only, and then we use the confusion matrix to show exactly which prediction were right versus the wrong one. So we will print uh, you can see confusion matrix, and on this we will print matrices dot confusion matrix. And for this we will use y test and y predict. So here we have predicted on the test data, and then we have checked the accuracy, and in last we have printed the confusion matrix. Let's run this. Here you can see the accuracies, model's accuracy is 50%. As if we run this again and again, you can see there is no change. There is nothing you can change. The model is going. 50% will get. There is no effect if we again and again running this. So if you ever think you can simply run that model again, it will change the accuracy. No, it's not. If if you think this is not a good accuracy or our model is not working well, this is not good. I accept that. I am agreeing with this, but I'm not saying our model is not working well. This is just because of as our data set. This is too much, or you can say this is too small to be worked with. As you can see, we have simply eight training, eight rows or eight different customers for training our model, and in which five are false and three are true. Two are not buying and false are buying. But the remaining two, in checking of that, the actual answer is 50, as I think the model is giving answer based giving both of them as buy, the giving the class as the buy because the majority of it is here this buy. That's why it, you can improve the accuracy simply by increasing or the data set by properly training our model with some epochs. More, I think more than 50 are good, but we are not going to using epochs here because it will consume too much of time. So let's go ahead and predict for new customers. And predict, and let's check if this is working well or not. We will using just comment here. We will use a male with age of 40 and salary of 1 lakh. Okay, we will use this one. So we create a new customer and here we go. New customer age is 40 and salary is 1 lakh and he's male. Now we will do the prediction. CL left dot predict. And this is for the new customer. And we will simply print predict. Okay, let's check this. Here you see the output is 1. That means he is going to buy that house or buy that product. I am again and again using the word house. So don't get confused. We are simply observing the customer's behavior so they can buy anything, a house or car or any product. So let's check with our data set and see is our model is working well or not. Let's simply print here. print here our data set df dot head, and we will print all our data here. Simply run this, and let's manually check this for age group of 22, salary is 20,000, gender is female, she is not going to buy, and again 25, 35,000 salary, gender is female, she is also not going to buy, and for the age 47, salary is 1,50,000, gender male, he is going to buy, and again age is 52, salary is 90,000, gender is male, he is going to be buy, and similarly age 46, salary is 61, gender female, she is going to be buy that product, and age 56, salary 21, and gender male, he is going to buy. Just one second. Here 50, and there again 80,000, he is going to buy. I This is simply a coincidence, but if you see all the female, or sorry, all the males here is going to buy, and again buy here also, and here also. All the male candidates in here are going to buy that product. Is That's why the male candidate, the printed, the answer is one? No, it's not because of that. You can also see the salary range. It's 1 lakh, and the minimum salary who is going to buy is that one, the 61,000, and the highest is 1,50,000. And this is higher or in between this range. I think that's why, and using both of this gives us the correct prediction. Just let's change this one as 1,000. Oh, sorry, 10,000. Let's check now how. Here you see. That's what I was talking to just back here, that our model is not too you our model is not as bad as you think. If the accuracy is only 50%, we are randomly giving the numbers, and if we are randomly giving the numbers, but it is predicting as same as I think it has to be give that answer. As you can see, the salary is only 10,000, and it is lower than the minimum salary, then it is not going to buy. And if we change the age 30 and salary, let's predict as 70 and making it female, I think it's going to be categorized. The minimum is 61. Who is going to buy? Okay, let's check it. Here you s- Here you see the minimum is 61, but they it is giving the right output as one, that she is going to buy, as we have used the female here, and it checked the salary and the ages, even with the gender, it predicted that she is going to buy. And with three different examples, we can see our model is working properly. Or if you just want to improve this one, or just simply want to increase the accuracy, you just have to increase the data set. simply use some different data set here, or simply increase this if you want to. Simply increase this only. If you increase or use a larger data set, the training part is going to be more accurate, then it automatically the accuracy will be increased here. Okay, our model is good enough to work with and to practice with. I think that's enough for today. And once again, I will explain you all things so you can easily do it again in your practice sessions. So I will suggest you to not to use this. If you want, you can use this, but in your practice session, simply download some larger dataset from any website or internet source. There are many different sources. You can use them. Or if you have any manual data, then you can also use them. And then use that data and see how this model is working. So, first we have imported all our important libraries and functions here. Then we simply created a data set. We have created a small data set, not too much or not too small, just a simple data set so you all can easily understand it. And then we divided, oh, sorry, before dividing that, we convert that data into data frame, and then we have divided all our four columns into features and target. The first three, age, salary, and gender as the features, and the last one brought as the target variable. Then we had used train test split. So for splitting our data set in the ratio of 8 to 2, 80% for the training part and the 20% for the testing part. And here's the simple data frame, or you can see this is our data set in the form of a data frame. And then we initialize our model, and we have trained our model. Then in this part we have visualization, how our training part is going on, the salary which is above this 48,500, and then there's the entropy, the sample spaces, the total number of rows on which our model is going or is training. There are total number of eight, and in which three are for not bias and five are for bias. And then we check our model's accuracy, and then we predict with uh, newer or unseen data. Okay, this is all we have done today. I think that's enough for today, coding part. And let's move back to our presentation part. Here we are. Let's moving forward. Finally, we check the results. We can use a confusion matrix to see exactly where the model succeed and where it failed. We look for a high accuracy score. If we hit 90%, we know our tree is very reliable and predictable of the customer's behavior. But as because of the low data set, our model is stopped in 50%, but then we use three different random data sets and it go predict the right class for that the buyers the customers behavior. So Just use larger data set for this model only. And then if you want to change anything or upgrade anything, you can. With that, thank you. Happy learning.